YouTube content creator, and your social media influencer. So now we need to touch another topic this time, but somewhat related to kinematic linear motion. This is kinematic angular motion. Kinematic, okay, angular motion. Wow, really? Yeah. Okay, the difference lies only in the adjective prior to motion, angular. But before we have linear. So this is the type of motion we will be able to describe, angular. So very obviously, it denotes two angle of inclination and rotation, like that, blah, 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 so and so. Okay? This is from angle. Okay, angle. Okay? Angle of inclination. Okay? Like that. Angle is the noun, angular is an adjective describing the motion. Just like linear. Linear is an adjective describing the motion. The root word is line. L-I-N-E. Same like this here. Okay? Kinematic meaning under the influence of velocity. Under the influence of velocity and force. Velocity and force, V and F, because an object will not move if there's no force and velocity at the same time. Okay? Get the point, and it's very clear. That's kinematic. Okay? Get the point, mga palangga akong hitad. Okay? You get the point? Ganon. Okay. Now we start with the basic illustration and schematic diagram. So, we have a circle like this. Always circle, guys. Things like this in, science and math, love circle. Small circle, big circle, and on. So this is a circle. So let us say it is a radius, capital R, with a central point. Let's say we consider this a nucleus. We interpret a nucleus always as a circle, right, or round. So we have the R here, like that. And then we have the entire diameter here, like that. So diameter is equal to 2 times radius. And our circumference will be 2 pi times radius. And our area will be equal to pi r squared. And also pi d squared over 4. So these are the geometrical calculations of a circle, right? It's going to be like that. Okay. Ganon. So now let's say this is the first radius, okay, perpendicular, and this is horizontal. Okay, like this. Perpendicular, horizontal, like this. Perpendicular, horizontal. Now we need to have S is our distance. Okay, let's say distance S, or should we say small letter d? It doesn't define what letters, as long as we can represent any letters. D is more closer because the first letter of distance is small letter d or big letter d, like that. Okay? It makes sense. Rather than putting any letters. Okay? Ganon. Ganon ba yun? Yes. And now, the time is here. Sharp. So we have established here an angle theta here. Okay, theta, something like that, right? Okay, it's gonna be like that. You get the point, mga palangga kung hitan. Okay. So S, okay, we have this S, D. Kaya di naman ni nato kaya, sorry kayo. So we have the formula of angle, which is the angular displacement. This one, angular displacement. Why? If this is a distance covering from R to R here, and we have also here the displacement in terms of the angle covered here. So this will become angular displacement, right? So angular, actually we can also call that as an angular distance, but in angular momentum, angular kinematic study is really angular displacement rather than angular distance. Okay, displacement talaga siya. Okay, the right term. More preferred than angular distance. Angular displacement because it creates a rotation. So angular displacement is equals to Okay? Meaning to say we have the angular velocity, like a W like this, okay, and the time. This is standard, okay? Standard equation, huh? Angular displacement equals to angular velocity times time. Why it's like this? Because it's just parallel to the equation of the kinematics linear. Okay, we have also displacement D is equals to the velocity times the range, okay, or the time. Time siya. Because if you try to compute the distance, it will become meters na siya. Okay? Ganon. So, time siya. So, muna siya yung nothing ani because of the original equation like this. Okay? So, this is the first equation. Oh, ganon. Okay, how can you compute for the velocity, angular acceleration, something like that? Okay, how can you compute that one? Okay, now here this is our illustration. We can create another formula for this. Okay, you will say in that way that we're gonna have velocity is equals to kaloka. Velocity kasi dili angular guys ha. Okay? Dili siya ang angular. Ano siya? Velocity is equals to angular velocity. Okay, velocity is angular velocity. Like ito na that. Ganon. Times the r. The r here is here ha. Okay? See? R. Okay, it travels with a velocity ng siya. R. Ato lang gi-introduce ang W in that. Okay? Like that. And then this equation number 2. Okay. And then we can also say displacement. Okay. Take note, this is linear. This is angular. Angular. Okay. Distance linear. Okay. Is equals to also the angular. So this is now angular displacement theta. Theta times r. This is equation number 3. Ganon. Okay? Imong timan ang guys that the linear will be equal to the angular times the range in your circle, in your memorization. Okay? So, linear velocity, linear displacement, and the other one is the linear acceleration. Linear acceleration is equal to the angular acceleration times the r. Things like this you can easily memorize because what you multiply by this is always the r. Right? In your angular, this circular shape. Okay? So, velocity, have that in your mind when we multiply by r. So, times the angular velocity because you're asking for the velocity. Angular displacement. So, multiply by angular displacement also. Okay, multiply by r. And then, acceleration. You multiply also by r, then angular acceleration. So, it's easy to memorize. Right? Ito po yung mga palangga kong hitan. Now, this VDA is linear, supposedly, okay, but since you account the angular chuva-chuchu, then it will become now tangential. Okay, tangential, meaning it creates a rotation to produce a hypotenuse, a base, and a height. This tangential, from the word tangent. You get the point, sir? Tangent theta, again, Pythagoras, tangent theta is equals to, okay, the opposite side over the base. Ganon. So, tangential. Okay, if we create an angle here, somewhere here, like blah, 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 so and so, this is here. See? Like that. So, we create here, we can create here, somewhere along the way, here. H and B, the tangent theta here. Ganun. Okay? You get the point? So, muna siya gitawag ko tangential. Okay? Because of the principle behind. Okay? And we consider the R because it is the rotational distance through its radius. Ganon. Diba? Because R is simply the radius also. Okay? You get the point. At yung kalimot na ang R, this is radius. Okay? You get the point. So we have now how many equations? 1, 2, 3, 4. And after that also, since we know that this is circular, then we have also to consider the centripetal acceleration. Okay, centripetal acceleration AC, okay, like that, is equals to V squared over R. Okay, ganon. Okay, V squared over R. So this AC in terms of this static radian, it will now become radial acceleration. So it's going to be AR. Okay, AR V squared over R. Meaning to say, centripetal acceleration is just equal to the radial acceleration. Ganon. O diba? Nakakaloka. Okay, since if you know that equation, you can simply say, central acceleration, centripetal acceleration sabi nila. Okay, and then this one is radial acceleration. Is also equal to angular velocity over the time. Okay, because velocity over time is also an acceleration in the linear motion. Since we're dealing with angular, we will replace the term angular velocity over the time. And that is your centripetal acceleration and your radial acceleration. Ganon. Okay, that's the point mga palangga ko. Ganon siya. So we can say pala siya na, ano din ka, centripetal acceleration, kaya mo naman siya, ano yun, is equal to W squared times the radius. Okay? Muna na yung AR. Okay, so doon natin formula ang AR. So how many? 1, ang radial acceleration. 1, 2, 3. It depends on the quantities to be solved. But normally, kanina ay angular velocity. Kani siya, kani o kani. Ganon. Okay. Now, since we are referring this to tangential, okay, we have also another equation. Equation 5, equation 6, equation 7. Okay, now. Okay? So, equation 7, equation, 7 na siya. Okay, now, if we have the angular velocity, how can we compute for the angular velocity? It's equation number 8. Our angular velocity will be now equal to, okay, the angular displacement, which is theta over time. Also, okay, we can have that also as an our equation. Boy, nakakaloka, where are you? Yes, it's here. Okay, so that's equation number 8. So many equations na. Okay, now this is angular velocity. Okay, ganun ang angular velocity, angular acceleration, blah blah blah. Okay, now how can you solve the angular velocity related to your R? Okay, so anaunin mo siya mga palangga. O dala lang, nangyari siya V, W, mo na siya ang relation sa V, akong giuna. O diba? So wala na, yun na yun. Okay? But if we try to compute, this is tangential acceleration, right? Tangential acceleration, and we have radial acceleration. So we will still also get the acceleration net acceleration, the same with the principle of forces, net forces. Remember? Here we also get the net acceleration. Okay, so how can we do that? So, net acceleration. Okay. So, di ba? Dahil nakikipumula sa itong brain cells, no? Okay, no, yun na siya natabo. Okay? So, acceleration net. Okay? Basis also with may tagura, but with relates to acceleration, we can come up to acceleration net raised to the power 2 is equals to acceleration radial AR or AC. It doesn't have meaning at all, it's just the same, right? Raised to the power 2 plus tangential acceleration na siya. You get the point? Tangential acceleration. Ana-ana siya, guys. O, tangential acceleration. O, di ba? Raised to the power 2. So, it will end up as your net acceleration is equal to the square root of acceleration radial raised to the power 2 plus acceleration tangential raised to the power 2. Now, be careful also in analyzing this one. Okay, if your problem will state at a constant velocity, blah, 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 so and so in the problem, so your acceleration tangential will be equal to 0 directly. Because you know the circle like this, and then you have the centripetal acceleration going here. Okay? Yan naman kay tangential here. The acceleration tangential. Just like a perpendicular with the base, the acceleration tangential. And then we have the AR here. Okay? Your ER is the acceleration directed toward to the center. That's like radial acceleration or your centripetal acceleration. Your A net will be here. Meaning the equivalent of acceleration net is also the hypotenuse in terms of acceleration. That's why you follow the Pythagorean theorem, but based on acceleration, chuba-chucho. Okay, so tangential acceleration, height raised to the power 2, and then radial acceleration raised to the power 2, because this is the base, this is the height, and this is hypotenuse. Okay, that's why we arrive for this. I'm telling you, if the problem will say at a constant p, the car traveling bubble on, so your A tangential will become to 0. Okay, you know why? Because if we try to project the cosine, okay, cosine, and we project an angle here, cosine angle, okay, like that, say, cosine angle of blah 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 is equals to A over the A net, ganon. Oh, now, so if your angle here is, let's say, 90 degrees, okay, because it is perpendicular, okay, cosine of 90 degrees, how much? Okay, where's the calculator? Cosine of 90 degrees. Anybody else? Where are you now? May calculator. I cannot see. Nakakaloka. Uy, saan ka na, Queen? Where are you? You are hiding. Saan na ka, Uy? Kenis. Hindi na ko kasubo. Ako calculator mga pala ng Queen. It's lost, but valid. I will see that later on. Sure ako siya. Okay? Nasaan yung calculator? Mga palanta ko kita. Uy, kita ko ito dito. Okay, ra. So, yun tika ako. Cosine 90 degrees mga palanta ko kita. Pila. Cosine 90. See? Cosine of 90 is equals to 0. That's why we will say the tangential acceleration is equals to 0. Okay? Ito po yung mga palangga kong hitad. Ganun siya talaga. Okay? Okay, ma-0 mag-yun siya. Let's say, cosine theta. I-try daw na ito ang tangent 90 degrees. Tangent 90 degrees may ma-project anak. So it's equals to the, tangent, it's gonna be, A over A net. Okay, so tangent of 90 degrees. Okay, okay, ano ba siya? Atong sugod sa uno, para ita maglibog. Okay, so cosine of 90 degrees. Pwede mo ako. Uy, nakakaloka. Cosine of 90 degrees is equals to, this gonna be AR, radial acceleration over hypotenuse A net. Okay, like that. Get the point, but we are on the tangential. So we cannot derive the tangential, so ECAS. So let's proceed to sine theta. Okay, actually the cosine of 90 degrees is also 0. No problem. Try the sine. Sine of 90 degrees is equals to the A tangential. Muna na siya, tangential diri. A tangential over A net. Okay, so A tangential is equals to sine 90 degrees times A net. Okay, first time we derive, guys. Let's see if this is 0. Because by the theory, it will become 0. Let's check. Excited! Paano kaya ito mga palangga kong hitag? Okay. Okay. Sine 90. Oh, it's gonna be 1. 1. Sine 90 is 1 times A net. There is a value, but the sign is 1. Okay? Like that. If you consider that 1, you have to substitute it here, like that. Okay? So there must be an A net if we considering the sine theta. If we considering the cosine theta, there's no A net. Because it's 0. How about tangent? Okay, so tangent, yeah, okay. It's gonna be like a tangential, yeah, okay, sakto siya. And then, ano ko sa tangent? Tangent theta is equals to, a tangential over a radial. Okay, let's say, okay, a tangential is equals to tangent theta times acceleration radial. Now, tangent of 90 degrees. Okay, ako yung kitag sa taksa para pamatunan ako ba. Char! Tangent of 90 degrees. Okay, tangent 90 degrees ang pangagutan. Uy, 90 tangent. Tangent 90. Okay. Tangent of 90. Okay, pila man siya. Charot. Okay. It's gonna be 0. So, it's gonna be, that's why pala ma-0 din siya. No? Dali. Okay. Kaya pala. Okay? So, now just I know. Really? Okay. You get the point mo pala, yeah. Because, di ba, law of right triangle, di ba right triangle, makakreate pa yung mga 90 degrees, right? It's a right triangle. Correct ba? Correct if I'm wrong, right? 90 degrees, 90 degrees ang right triangle, right? Right angle. Okay? Basta, what I remember is that like that right angle, 90 degrees. Maybe I'm wrong, but I don't know. Just based on my memory. Okay. Ay, nakakaloka dyan. Basta nalagay dito yung constant speed theory na lang, ngayon na nag-prove. Total, ako alam sila ko pag-prove, pero at least, at constant speed, gano'n chupa-chucha, may mga acceleration tangential, wala na good siya, zero na good siya. Unless it has a number. Specified pa, gano'n. Diba? Okay, equivalent sila siya sa atong kuan guys, atong sa linear na itong velocity is equals to the square root of velocity x component squared plus velocity y component squared. Na kaning v siya, mo ni siya, calculate the final velocity before the ball will hit the ground. So, mga trajectory, projectile, mao gini siya nga equation na ilain. So, yung ganyan, imong timanan, you should you should put in your brains as well. If the question will say, what is the velocity before it hit the ground? Before it hit, muna siya nga formula. Kaya after hitting the ground, kaya mulain naman sa imong formula. Ang imong final mo, zero ba ya? What is the velocity? What is the velocity upon reaching the ground? Of course, the final will become zero. The final velocity will become zero. Kinanago sa yuta. Okay? Then, ang hindi mo na sa initial velocity mo baon. But here, what is the final velocity before it hit the ground? Muna siya, exclusive ani. Okay? Ay, napuro na dahil dito ani na yun. Char. Di ba? Puro madali. Okay, maybe we can derive also that doing the component, ganon. O, di ba? Okay, ganon siya. Any questions so far? Wala pa ko kakunin sa mga formulas. Okay. Later na lang, mabalik ako sa katong mga chuba-chucho. Okay? Thank you so much for watching this live streaming about angular motion. But there are still 4. I need to, to refuel my brain cells. And rest for a while. Thank you so much. Bye-bye, God bless everybody. Kakaloka.